In this module, you will learn how to write user-defined functions in MATLAB. After you complete this module, you will be able to identify the differences between built-in functions, user-defined functions, and scripts. You will also be able to identify characteristics of a function definition line and create your own user-defined functions. The contents of this module assume that you are familiar with the use of templates and script files in MATLAB. In MATLAB, you have worked with built-in functions such as sine and cosine, and scripts or M files. The table here shows the major differences between functions and scripts. Functions are MATLAB code that accept input arguments and produce output arguments, while scripts are simply a sequence of MATLAB commands. Functions have their own separate workspace, and variables created outside the workspace cannot be accessed by functions. Scripts use the global workspace and have access to all variables in this workspace. Functions communicate with other functions using input arguments and output arguments, while scripts communicate with other scripts by modifying global variables. If there is an operation that you want to use frequently that doesn't already exist in MATLAB, you can create a user-defined function. User-defined functions are M files with a specific structure. The first line of a user-defined function is the function definition line. This line defines the function name and specifies a list of input and output variables. Output variables is a comma-separated list of variables calculated within the function and returned to the MATLAB workspace. Input variables is a comma-separated list of variables that must be passed to the function. Function name is the name of the function. This name must be the same as the file name you use to save the M file. Always put the function definition line on line number 1 of the file before anything else. The word function must be lowercase, and the function name must follow the same rules as the variable names. They must start with a letter and can contain letters, digits, or underscores. Following the function definition line, include comments that describe the function. These comments must be a solid block of commented lines with no blank lines. These comments will appear when you type help, followed by the name of the function in the command window. Let's take a closer look at the function definition line. Because the number of input or output arguments can vary, the function definition line can take many forms. Let's first look at output arguments. If the function has 0 outputs, use empty square brackets or simply no text and no equal sign. If the function has a single output, the square brackets are optional. If the function has more than one output, use square brackets to create a matrix of outputs. Now let's look at input arguments. If the function has 0 inputs, follow the function name with an empty set of parentheses or no parentheses. If the function has a single input argument, put this argument in parentheses following the function name. If the function has more than one input argument, separate each argument with a comma within the parentheses. Never use square brackets for input arguments. Input and output arguments can be any mix of scalars, vectors, matrices, strings, or cells. You have used the course script header template to create MATLAB script files. Another template, the function template, is also provided to help you create user-defined functions with a uniform look. This file is similar to the script header template and can help you create a function with a uniform look. The function template has several sections. At the top is the function definition line. Remember that the function definition line must always appear on line 1. Below this is the space for detailed descriptions of the function as comments. Within these comments, You should repeat the function definition line and include details on the input and output arguments, including variable names, units, and what each variable represents. At the bottom of the template is the header where you will fill in your name and identifying information. Below this header is the space you will use for the rest of your function code. In this space, you will see normal sections for inputs, calculations, outputs, and results. Remember the following about working with functions and the function script. First, only variables that are already in the workspace are passed to the function as inputs. Second, before the end of the file, you must define any output variables that appear in the definition line. Third, in the input section, do not overwrite any inputs that were given in the function definition line. The names and order given for the argument variables in the function definition line are tied to their use within the function rather than in the workspace from which the function is called. In other words, the name used for each variable in the definition line is the name that must be used in the function file. When the function is called from another workspace, the order of the arguments determines the corresponding variable within the function. Make sure that the current folder in MATLAB is the folder that contains your function. To execute your function, copy everything after the word function in the function definition line and paste this into the command window. We also call this line a function call. For example, if the function has one input and one output, enter my output equals my function parentheses my input in the command line, where my output and my input represent the actual output and input variables. You can choose the variable representing my output at the time of execution, but the input variable must already exist in the workspace. The names of the variables in the function call do not have to match the names of the variables within the function file. However, since MATLAB is case sensitive, any capital letters in the file name must also be capitalized in the function call. Let's look at an example to see how the order of arguments in the function call affects resulting calculations. Remember that the variables used in the function call are independent of the variables in the user-defined function. Only the order matters. Shown here is the code for simple user-defined functions with two inputs, x and y, and one output, z. One basic calculation is made using this function, z equals x minus y. For this example, we will define x as 2 and y as 3. Shown here is the function call we would type into the command window. Notice that the first variable in the call is x and the second is y. When MATLAB executes the function call, these values are sent to the user-defined function in this order. So, in the function, x is assigned a value of 2 and y a value of 3, and z is calculated to be -1. Once MATLAB determines there are no more lines of code in the user-defined function, it returns the specified variables to the original function call. In this case, the only output is z. So MATLAB returns the calculated value of z to the function call in the command window. The variable z is now assigned to a value of -1 and appears in the command window workspace. Using the same user-defined function, let's try a different call. This time, we specify the first input to my function to be y and the second to be x. This is basically a reversal of the previous example. Once the function call is executed, the value of y in the command window workspace is assigned to the variable x in the user-defined function. Further, the value of x in the command window is assigned to y in the user-defined function. Remember, variable names have no effect on user-defined function calls. Only the order of the input arguments has an effect. The value of z is then found to equal 1, which is returned to the command window as an output of the user-defined function. This example demonstrates how important the order of input arguments is to proper execution of a user-defined function. Let's look at another example. In this example, we will take the script file from a problem previously solved and convert the code to a user-defined function. Review the problem description shown here, as well as the script file created to solve the problem. Click Continue when you are ready to continue. Begin by opening the function template. Write the function definition line with two outputs, the heat output and the number of elements generating heat. Name the function air conditioning and specify four inputs: the number of lights, the number of computers, the heat generated by a light, and the heat generated by a computer. Save the file as airconditioning.m. Next, complete the function definition description by repeating the function definition line and identifying the input and output arguments. We have already completed the regular header with identifying information. Next, copy the code to calculate heat output from the original script file. Make sure that the variable names match those in the function definition line. Now add a line of code to calculate the number of elements generating heat. Save the file and return to the command window. Define the number of lights as 4, the number of computers as 6, the light heat as 100, and the computer heat as 200. Call the function with these inputs but no outputs. MATLAB returns one output. This output corresponds to the first output in the function definition line, heat output. When a function with multiple outputs is called without any specified outputs in the function call, only the first output will be returned as the temporary ans variable. If we call the function again and specify heat output as the output, we get a similar result. We can also call the function with both outputs. With the proper results displayed in the command window, copy the function call and the results. Paste these results following the calculation section of the function file. Now that you have completed this module, you should be able to identify the differences between built-in functions, user-defined functions, and scripts. You should also be able to identify the characteristics of a function definition line and create your own user-defined functions in MATLAB. This module covers only some of the concepts on this topic. For additional information, refer to other available sources. Also, remember that you can view this module at any time and as many times as you desire.